Learning how to make a bar bending schedule is the most important skill that every civil engineer and quantity surveyor should know. It essentially helps us to budget properly and know exactly how many steel bars you need to purchase for your project. You understand structural drawings properly in detail, and that helps you to avoid any mistakes when fixing steel bars in any structural member, and also provides the cutting length and the bar bend shapes that can clearly be understood by everyone on site. In this video, you are going to learn an easy step-by-step guide on how to make a bar bending schedule for the slab the easiest possible way that literally anyone on this planet can understand. So be sure to watch this video till the end, because you don't want to miss this. Let's first clearly understand what a slab means. A slab is this horizontal structural member that transfers load to the beams. And right now, let's dive into these 4 easy steps to make a bar bending schedule for the slab. The first step is understanding how steel bars are arranged in the slab. Let me show you exactly how. The basic knowledge or fundamental knowledge about the arrangement of steel bars in the slab is that we use steel bars of this shape all around the perimeter of the slab. Considering a slab of 20 meters along the length and 5 meters along the width, load is transferred from the slab to the beams, then from the beams to the columns, then from the columns to the foundation, and then from the foundation to the soil or rock. These are beams covering the perimeter of the slab. These shaded points are the columns. Then what covers all this area is what we call the slab. For our case here, we can generate grid lines 1, 2, 3, 4 along the length, then grid lines A, B, C along the width. And we can decide to name these columns as C1 and C2 for easy identification. Columns given the same name have the same size or dimensions. This is a single steel bar arranged along the width like this. The standard length for one steel bar is 12 meters, and due to the fact that we have 5 meters along the width, that simply means that we have no overlapping, and this will be a single steel bar. But of course they are arranged along the length, and this length is 20 meters. These steel bars are at a spacing of 150 mm center to center, therefore we need 135 of them to cover this entire length. We write the description outside the perimeter of the slab, so this is 135 steel bars of H12, bar mark 01 at a spacing of 150 mm center to center from one steel bar to another for bottom one. In a structured drawing, bottom bars are always represented as a dotted line, whereas top bars are always represented as a thick line. Then along the length, 20 meters is longer than the 12 meters standard length of a single steel bar, meaning we shall have to cut different steel bars and join them together. The first one will be of this shape, and also another one on the other side of a similar shape, then joined together by this bottom bar. Therefore, this steel bar shape starts from here up to here. Same this side also. So if we are to name them or describe them from the rest, this will be 35 steel bars of H12, bar mark 02 at a spacing of 150 mm center to center for bottom 2 and top 1. This is the bottom 2 part and this is the top 1 part. Same this side also. This is 35 steel bars of H12, bar mark 03 at a spacing of 150 mm center to center for bottom 2 and top 1. We then have this steel bar which connects the 2 steel bars, and this will be 35 steel bars of H12, bar mark 04 at a spacing of 150 mm center to center for only bottom 2. Before proceeding, here are the 3 basic rules you have to consider when preparing a bar bending schedule for the slab. Rule number 1 is considering the overlap. An overlap is this extra length that enables the safe transfer of load or stress from one steel bar to another, which can be gotten using the formula overlap is equal to 50D, where 50 is a constant and D is the diameter of the steel bar used in the slab, and therefore, since we are using steel bars of 12 mm bar thickness, that simply means that overlap here is equal to 600 mm. We are considering a wall of 200 mm thick, and that simply means that the center line is cutting through the center of the wall, one side as 100 mm and another side as 100 mm to make the total wall thickness as 200 mm. The third consideration are concrete covers. We are using 25mm concrete covers everywhere in the slab, that is at the bottom, on top, and the sides of the slab. These three considerations work hand in hand with each other, and that simply means that every time we are working on a calculation including overlap, we don't have to include spacer blocks along the horizontal distances. The small distances of concrete covers are negligible and are compensated at the other end of the steel bar at the overlapping position. Let me explain to you exactly what I mean in this example. This is a slab of 12 meters, 50 millimeters along the length and 5.8 meters along the width, as the measurements taken from the center line of the wall or the center line of the beam. From the top view, we have 1, 2, 3, 4, 5, 6, 7 steel bar shapes, and when we extract them out of the slab, that's what we exactly draw in the bar bending schedule table under the description column. And the task now is to find out the dimensions for each side. Let's look at this particular example. As I've said before, bottom bars are always represented as a dotted line, whereas top bars are always represented as a thick line. We are going to work on each steel bar shape separately. The first steel bar shape is this one that runs along grid line 1 to grid line 2, with the steel bars arranged from grid line A to grid line C. Let's find out the dimensions for this steel bar shape. Since the wall is 200mm, when you deduct 25mm concrete cover on the other side of the wall, this side of the wall remains as 175mm. This is 175mm. Add 1.7 meters internal surface distance, then add 200mm wall thickness here, and then add 1.8 meters to get 3 meters 875mm. For academic purposes or for the sake of passing exams, we take this figure as 3 meters 875mm, and when doing practical work on site, we take this as 3.9 meters to ease cutting. Then for this lower side, also get 175mm, add 1.7 meters, add 100mm half wall thickness, then add 300mm half overlap to get 2 meters 275mm, which is equivalent to 2.3 meters. And that's what we write here as 2.3 meters. Then for this other side, simply get the slab thickness, which is 200mm, deduct 25mm concrete cover on top and 25mm concrete cover at the bottom to remain with 150mm, and that's what we write here. These steel bars will be covering this inner surface distance from grid line A to grid line C. Therefore, this inner surface distance is 5.6 meters, and for every distance of 5.6 meters, we need 40 steel bars, which will be fixed from grid line A to grid line C. Let's describe this steel bar shape now. These are 40 steel bars that we need to cover a distance from grid line A to grid line C of H12. H12 is the type of mark or steel bar thickness. The bar mark as 01. The bar mark shows us where steel bars start and end from in a structured drawing. Each steel bar shape has its own bar mark that differentiates it from the rest, and then at a spacing of 150mm center to center from one steel bar to another for bottom 2 and top 1. Bottom 1 bars will run in this direction. Bottom 2 bars will run in this other direction. Similarly, top 1 bars will run in this direction and top 2 bars will run in this other direction. And that's what we exactly fill in the table here. Bar mark as 01, type of mark as H12, number of members as 1 because we have one slab of the same kind, number of bars required here as 40. Add the 3 sides of the steel bar to fill this column of the total cutting length. The second steel bar shape that we are going to look at is this one on the right. The length of the bottom bar side is 175mm. Add 2.7 meters. Add 100mm half wall thickness, then add 300mm half overlap to get the total cutting length as 3 meters 275mm, which is equivalent to 3.3 meters. For academic purposes, we take this first one, then for practical work, we consider 3.3 meters to ease cutting and bending. The top side is simply 175mm plus 1.8 meters, which is equal to 1 meter 975 millimeters, and we take 2 meters. For this third side, we simply get the slab thickness, which is 200 millimeters. Deduct 25 millimeters concrete cover on top and 25 millimeters concrete cover at the bottom to remain with 150 millimeters, and that's what we write here. Let's describe this steel bar shape. These are 40 H12 steel bars. Bar mark is 02 at a spacing of 150 millimeters center to center from one steel bar to another for bottom 2 and top 1. And that's what we fill in the table here. This direction of arrows shows the arrangement of the steel bars in the slab. The shape of the steel bar starts from grid line 3 to grid line 4. Bar mark is 02. Type of mark or steel bar thickness as H12. Number of members as 1 because we have one slab of the same kind. Number of steel bars as 40. 1 multiplied by 40 we get 40. Add the 3 sides to fill this column as the total cutting length. The third steel bar shape is this one, starting from grid line 2 to grid line 3 that are arranged towards the north. The total length of the bottom side is 300 mm half overlap. Add 7 meters 250 mm from grid line 2 to grid line 3. Add 300 mm on the other side to make total as 7 meters 850 mm, and that's what we write here as 7 meters 850 mm. The overlap here comes to 600 mm, and also the total overlap here comes to 600 mm. Let's describe this steel bar shape. They cover this whole internal or inner surface distance of 5.6 meters, and for every distance of 5.6 meters, we need 40 steel bars. So this is 40 steel bars of H12, bar mark as 03 at a spacing of 150 mm center to center for bottom 2 bars. That's what we exactly fill in the bar bending schedule table. This is bar mark 03, type of mark or steel bar thickness as H12, fill in the number of members, number of bars in each, and the total number of steel bars here, and also fill in the total cutting length in this column here. This is the fourth steel bar shape. This is the top side that is thick, then the bottom side is dotted. The internal surface distance here is 5.6 meters. Add 175 mm on one side and also 175 mm on the other side to get total as 5 meters 950 mm for the bottom bar. The top side here is also 175 mm plus 1.8 meters to get total as 1 meter 975 mm, which we take as 2 meters. Other steel bar shapes can easily be extracted from the main structure drawing to the bar bending schedule table. Another steel bar shape which is not always provided for in the structure drawing and you always have to provide for it is a chair bar. This is its shape. These chair bars help to firmly hold top bars and bottom bars together and prevent them from sagging at the time of powering concrete. Chair bars also help to maintain the required clear concrete cover. Personally, I normally use default measurements of 400 mm legs and 500 mm head. Then I calculate the height depending on the slab thickness, and for this case, since the slab is 200 mm, get 200 mm, deduct the 25 mm concrete cover on top and 25 mm concrete cover at the bottom. Also deduct bottom 1 and bottom 2 bars in the slab, and also deduct top 1 and top 2 bars in the slab to remain with the height. The answer you get is what we write here as the height of the chair bar. There is no bar mark. Then for the type of mark or steel bar thickness. For the type of mark or steel bar thickness, we use the same bars as used in the slab, and for this case, we have H12. Fill in the number of members, number of bars in each, and the total number here. And lastly, fill this column as the total cutting length. That's the end of this video about how to make a bar bending schedule for the slab, and also end of the entire playlist about how to make a bar bending schedule for all structure members. I hope you get something from it. In case you missed any video, click on this video here on the screen. Thank you so much for watching till the end.